Welcome to The Explainer. Today, we're unraveling a genetic mystery that completely rewrites how we picture our deep past. For generations, there's been this incredibly persistent myth about ancient human life. Picture it, a tiny, isolated prehistoric camp, maybe 20 people huddled around a fire, trapped with the exact same relatives for thousands of years. It's kind of claustrophobic, right? And I mean, if you think about it, if only a couple dozen people lived in your entire world, the logic seems absolutely unavoidable. Eventually, everyone becomes someone's sibling, cousin, or, mysteriously familiar-looking grandfather. But, as we're about to see, our DNA tells a wildly different story.
So, that brings us to the core question we really have to ask. Did ancient humans actually reproduce with their close family members? Logically, if you spent your entire life in a tiny hunter-gatherer band, who else is there, right? Without modern transport, social media, or even a basic family tree, it feels like accidental inbreeding wouldn't just be possible, it'd be a mathematical certainty. You'd completely expect prehistoric genomes to be incredibly tangled up.
Okay, let's dive into this because ancient DNA has finally entered the chat, and the results, they are staggering. Researchers examined the genomes of 1,785 ancient individuals across various regions and time periods, and out of that massive sample, only one, literally exactly one single individual carried the genetic pattern you'd expect from parents who were first-degree relatives, like a brother and sister or a parent and child. One out of almost 2,000. No way, right?
To put that into perspective, when researchers expanded their search to look for unions between slightly more distant relatives, like first cousins, they found that substantially fewer than 10% of the parental unions in their sample actually fell into that category. Over 90% of these ancient people were the product of distant or completely unrelated unions. So, while ancient humans did occasionally reproduce with close family members, they clearly worked surprisingly hard to avoid it. But how on earth did they manage this in such small groups?
Well, the answer starts with correcting a really fundamental misunderstanding of what an ancient community actually looked like. Population size is absolutely not the same as camp size. Yes, sure, a hunter-gatherer group might travel, sleep, and share food in a daily camp of only 25 people. But those groups were never sealed biological containers. That small daily camp was really just a node in a massive, highly fluid social network. Individuals moved between camps, bands separated and reunited all the time, and seasonal gatherings brought hundreds of people together at once.
And we actually have the physical receipts for these prehistoric networks. Archaeologists routinely find stone tools crafted from raw materials that originated incredibly far from where they were eventually dropped. We find marine shells deep inland, right alongside traded pigments and ornaments. Now, people weren't just swapping rocks and shells. They were exchanging knowledge, hospitality, food obligations, and, crucially, partners. Because of this high degree of social connectivity, their impressive genetic diversity wasn't necessarily some conscious, strict anti-inbreeding program. It was just a natural side effect of being highly socially connected.
Now, what's really interesting here is how far back this behavior actually goes, way before modern humans. Over in Chagaskaya Cave in Siberia, dating back 54,000 years, researchers found a group of about 20 Neanderthals. Now, their overall genetic diversity was very low, which suggests a tiny, isolated community. But their mitochondrial DNA, which is inherited exclusively through mothers, showed much greater diversity than the paternal lines. The absolute best-fitting explanation here? Women were moving into this community from other Neanderthal groups. So even on the absolute edge of their known world, their mating pool was deliberately kept larger than their physical cave.
You might be wondering, though, how did geneticists actually know who made it with who thousands of years ago? Well, they look for something called runs of homozygosity. Simply put, these are stretches of DNA where both copies of a chromosome, one from the mother and one from the father, are completely identical. This is essentially the ultimate biological method that dead people use to reveal relationships they never had the chance to write down. It's like this. Imagine your genome is an enormous book. If your parents are only distant relatives who share ancestors from far back in time, you'll just inherit scattered, matching sentences throughout your book. But if your parents are siblings, you're going to receive entire matching chapters because your parents inherited huge overlapping blocks of DNA from the exact same recent source. Geneticists can spot these massive identical chapters instantly. And the reason avoiding these identical chapters is so absolutely crucial comes down to biological danger, specifically matching harmful recessive variants. Look, every single one of us carries potentially harmful mutations. Usually it's fine because a healthy copy from one parent masks the bad one from the other. But if closely related people, like siblings, reproduce, there is a massive statistical spike in the risk that their child is going to receive identical harmful variants from both sides. This causes what's known as inbreeding depression, a much higher risk of congenital disorders, reduced fertility, and weakened immunity.
Now, ancient humans definitely didn't need to understand chromosomes to observe these consequences. But observation is really only half the story here. Our biology actually teamed up with our psychology through something called the Westermarck effect. See, the human brain doesn't need a cheek swab genetic test. It uses childhood familiarity as a rough, though imperfect clue. Essentially, close domestic association during your early childhood heavily reduces sexual attraction later in life.
I absolutely love how the source material sums this up. Nature did not install an infallible incest detector. It installed an extremely aggressive sibling vibe. Just think about it. The person who stole your food every morning, the one you squabbled with throughout your entire childhood, is psychologically ruled out by your brain as your ideal reproductive partner. It's just a remarkably simple, elegant survival mechanism.
And human cultures took this natural instinct and totally formalized it, obsessively classifying kin to organize society. To us today, a cousin is just a cousin. But ancient kinship systems, they were incredibly specific. For example, parallel cousins, meaning the children of a parent's same-sex sibling, were often socially classified as forbidden siblings. But cross-cousins, the children of a parent's opposite-sex sibling, were completely different socially. They were actually often preferred partners. By making these exact distinctions, early societies systematically circulated partners between lineages, transforming marriage from just mere attraction into vital social infrastructure and lasting alliances.
Section 4. The exceptions, when power broke the rules. Let's move to and see how this builds, because while nature and society set up these incredible guardrails to prevent close inbreeding, there are some rare, pretty dark archaeological anomalies where these rules were shockingly completely shattered.
The DNA reveals some truly extreme exceptions. For instance, in a 5,000-year-old prestige tomb in Newgrange, Ireland, researchers found a man whose parents were first-degree relatives, very likely a brother and sister. Even more grim, in a Bronze Age cave in Italy, geneticists analyzed a young boy with nearly 800 centimorgans of long homozygous segments. That is a massive amount of shared DNA, and the data confirmed a father-daughter union. And, historically, we know the Ptolemaic dynasty of ancient Egypt heavily embraced royal sibling marriages, with rulers like Cleopatra descending from a highly looped family tree.
When looking at all this data, we have to remember a deeply sobering truth. Prehistory preserved the scandal. It deleted the testimony. The genome of that boy in Italy perfectly records the biological act of reproduction, sure, but it absolutely does not record consent. DNA can't tell us if these unions were a result of abuse, coercion, religious fanaticism, or isolated acts behind closed doors. We are only seeing the genetic aftermath.
But why did powerful elites ever institutionalize this? Why did rulers in ancient Egypt or the Inca Empire actually encourage sibling marriage? Well, it was a highly calculated political tool. By breaking the ultimate taboo, they were basically proving that the ordinary rules of humanity simply did not apply to them. It maintained a so-called divine identity. It consolidated their political legitimacy. It kept wealth tightly locked within a single lineage. And it quite literally converted a universal human taboo into an exclusive royal privilege. So the crucial point is that we have to be really careful with our data. We celebrate that incredible 1 in 1,785 statistic, but remember, archaeology only analyzes who survives and who actually gets formally buried. It is a really uncomfortable but real possibility that this number might be artificially low. Infants born from forbidden unions who suffered severe genetic consequences might have been concealed, they might have lacked formal preserved burials, or they were just intentionally omitted from the archaeological record by their communities.
But despite those elite exceptions, the overarching story of humanity is one of brilliant social engineering. Our ancestors survived through these amazing nested circles of connection, starting at the household, expanding out to the daily camp, reaching further to the lineage, connecting with the neighboring band, and eventually participating in vast trading networks. This perfectly balanced having close, trustworthy daily companions with maintaining distant allies who could bring in unfamiliar immune variants, new skills, and proof that the world continued beyond the next ridge.
Ultimately, ancient humans were remarkably mobile and socially intelligent. They didn't avoid inbreeding because they understood DNA. They avoided it because they fundamentally understood the immense value of connection. Every time a new group appeared on the horizon bringing unfamiliar faces and stories, it wasn't just a trade opportunity. Encounters on the horizon kept humanity's family tree from becoming a circle.
It really makes you wonder, doesn't it? In an age where we feel so globally connected by technology, are we actually maintaining the kind of deep, survival-level social networks our ancestors mastered thousands of years ago?